Now we will study the importance of Cobb-Douglas production function. Cobb-Douglas production function is based on the empirical study of two uh, Americans. Okay, the first one was Paul H. Douglas and second one C. W. Cobb. So this function is named after two American manufacturers, Cobb and Douglas. It is a linear homogeneous production function of degree 1. The degree of the function should be 1 over here, and which takes into account two inputs. It takes into account two inputs. One is labor and the other one is capital for the entire output of the manufacturing industry. So the general form or the simplest or the basic form of Cobb-Douglas production function is Q is equal to AL alpha K raised to power beta. This is how we denote our simple Cobb-Douglas production function. AL raised to power alpha K raised to power beta. Now L stands for labor and K stands for capital. Alpha stands for the proportion of labor that is used in the production process, and beta stands for the proportion of capital that is used in the production process. So Q is the Q is the level of output that is produced in the economy. Both alpha and beta, they are positive parameters. Their value cannot be negative because they are the proportions that are proportion of labor and capital that are used in the production process. The equation tells us that output, this Q level, directly depends upon two factors. One is labor and the other one is capital. Labor L denotes the labor and K is used for capital, and the part of output which cannot be explained by labor and capital is explained by the insertion of the term A in this function, which is often called as the residual, or the which is often known as the technical change. So therefore this A is of importance over here. This is basically known as residual, okay, which refers to the technical change, RESIDUAL, and it is known as residual because it explains that part of the production process which cannot be explained by labor and capital, and this residual is known as technical change. Okay, so therefore, Cobb-Douglas production function, the basic form of, or the most general form of Cobb-Douglas production function is Q is equal to AL raised to power alpha into K raised to power beta. Both alpha and beta should be positive numbers. They cannot be negative, and most generally its value lies between 0 and 1. It can be 0, it can be 1, but basically in general the value should lie between 0 and 1. Now the Cobb-Douglas production function can take the form of examples like if Q is equal to AL raised to power 3 by 4, K raised to power 1 by 4. Another important property over here comes is that, as you know, that this 3 by 4 is alpha and 1 by 4 is beta, we should know that alpha plus beta is always equal to 1. That is, alpha plus beta is equal to 1. Now if we have 3 by 4, the value of alpha, and we have the value of beta is equal to 1 by 4, if we add both of them, we get 4 by 4, and 4 by 4 is equal to 1. Now suppose if its value is not equal to 1, then it means that there is no complete utilization of labor or capital in the economic system, or there is no efficient allocation of these two resources. The coefficient of laborer in this function measures the percentage increase, okay, in the quantity of output that would result from 1% increase in the labor. What is this L showing? The coefficient of L is showing that The percentage increase in the output would result from a 1% increase in the labor while holding the capital constant. Similarly, what happens over here is that we can also find out the percentage increase in output due to percentage change in the um, due to increase in the value of the capital by 1 unit. So to produce 100 units of output, that is, suppose if the value of Q is equal to 100 units. To produce 100 units of output, units of capital and OK units of capital and OL units of labor are used. That is, over here the diagrammatical explanation is also shown. In order to produce 100 units of output, let's suppose this is OL and this is OK. Okay, OK units of capital and OL units of labor are used to produce 100 units of capital. Now, if the output was to double, that is, if suppose instead of 100, the firm wants to produce or the firm is producing 200 units of output, then what will happen is that the inputs of labor and capital will have to double. Then the inputs of labor and capital should double. If there are 5 units of labor, 10 units of labor should be now utilized. If there are 10 units of capital, 20 units of capital should be now utilized. This is the double curve. Okay, these should be straight lines. Okay, so therefore the output is exactly double of so therefore 200 is the exact double of 100 units of output. In the same way, if the output is raised threefold to 300 times, then the unit of labor and capital should be increased by threefold as well. So therefore in this case, in this particular case, then we will have isoquant 1, isoquant 2, and for the triple one, that is if 300 units of output are to be produced, then we will have isoquant 3. We will have 3 different isoquants showing the 100 units of output. Okay, let it be 1, that is for 100 units, this let it be 2 for 200 units of output, and this one be 3 for 300 units of output. This is now K, this is now K2, this is now L2, this is L3, and this one is now K3. Okay, so this is the Cobb-Douglas production function, which we basically study. What happens is that we also join these points. Clear, let it be named as S curve. Okay, so there are a few criticism of this Cobb-Douglas production function. What are they? We will study them one by one. The Cobb-Douglas production function considers only 2 inputs. The first criticism is about its inputs. Cobb-Douglas production function involves only 2 inputs, that is, one is labor and the other one is capital. The first criticism comes to the number of inputs. And it neglects some important inputs like raw materials which are used in the production. It is therefore not possible to generalize this function to more than 2 inputs. Okay, therefore we cannot generalize the Cobb-Douglas production functions for those functions which we can involve more than 2 inputs, whereas it involves only the utilization of 2 inputs. Most probably or most generally we can say that those 2 inputs are capital and labor. Now the second criticism is that in Cobb-Douglas production function, the problem of measurement of capital arises. Why? Because it takes only the quantity of capital available for production. That is, the measurement of capital is another problem in the Cobb-Douglas production function. Why? Because it takes only the quantity of capital that is available for production, but the full use of available capital can be made only in the times of full employment. This is unrealistic because no economy is always fully employed. Third one is Cobb-Douglas production function is criticized because it shows constant returns to scale. A very important criticism. The constant returns to scales prevails in the Cobb-Douglas production function, and it only studies this behavior of scales. Therefore, Cobb-Douglas production is criticized for showing the constant returns to scale always, but constant return to scale are not actuality for either increasing or decreasing the returns to scale are applicable to the production. Therefore, it is not possible to change all inputs to bring a proportionate change in the outputs of all industries. Just like we studied over here, we said that in order to produce 100 units of output, the firm has to utilize K and L units of inputs. But when we double the output level, that is, if the firm wants to produce 200 units of output, then according to Cobb-Douglas production, the inputs should be doubled. This is now constant returns to scale. But the criticism over here is that it is not necessary that in order to change the output, all the inputs bring a proportionate change. Okay? And in order to produce that level of output. Some inputs are scarce, maybe suppose capital is scarce or labor is scarce, especially the skilled labor, and cannot be increased in the same proportion as the one which is abundant input. On the other hand, inputs like the machines, entrepreneurship, etc., are indivisible. As output increases due to the use of indivisible factors to their maximum capacity per unit, costs always fall. So therefore, constant returns to scale does not always prevail. There can be other factors which can restrict the supply of the uh, factors of production, and therefore what happens is that it is not necessary that in order to produce 200 units of output, that is the double of 100, the input should always be doubled. Okay, the fourth criticism is about the substitution. That is, what happens is that Cobb-Douglas production function is based on the assumption of substitutability of factors, and it neglects the complementarity of factors. That is, what happens is in the Cobb-Douglas production function, we study the substitution of one factor for the other factor, but we neglect what we do is that we neglect the complementarity of the factors, that is how much one factor is complementing the use of the other factor. We are neglecting this important property. Therefore, Cobb-Douglas production function is also criticized for the ignorance of complementarity of one factor for the other factor, whereas it is only studying the behavior of substituting one factor for the other factor. Okay. Then we have the function is based on the assumption of perfect competition in the factor market, which is really unrealistic. Fifth criticism is about the perfect competition in the factor market, which we all know is unrealistic assumption. If this assumption is dropped, coefficients alpha and beta then do not represent the factor shares. An important thing over here to note is that if suppose we drop this assumption, that is the perfect competition in the factor market, what happens is that the coefficients of alpha and beta, which were 3 over 4 and 1 over 4 in our example, then they will not represent the shares of the labor and capital in the production process. And then the last criticism over here is that it is the aggregation of the problem. That is, the problem is taken as an aggregate problem, total problem. Okay. What do we mean by this? This problem arises when this function is applied to every firm in an industry and to an entire industry. Cobb-Douglas production function can be applied to the industry for which the two economists, mathematicians, or industrialists derived this particular function, that is by Paul H. Douglas and C. W. Cobb. This function cannot be applied to all the industries, or it cannot be applied to all the firms in an industry. In this situation, there will be many production functions of low or high aggregation. Therefore, Cobb-Douglas production function will not measure what it aims at measuring. Conclusion is that the practicability of the Cobb-Douglas production function in the manufacturing industry is a doubtful proposition. This is not applicable to agriculture, where for intensive cultivation, increasing the quantities of inputs will not raise the output proportionately. Therefore, in agriculture, here, okay, this is called, okay. This constant return to scale example or the assumption does not fall for the agricultural productivity examples. Well, it cannot be denied that constant returns to scale are a stage in the life of a farm, industry, or economy, but it is not necessary that in order to increase the output, constant returns to scale should prevail at all cost. It is another thing that the stage may come after some time and for a very shorter while as well. Now, apart from the criticisms, we have also some important factors which we can derive from the usage of Cobb-Douglas production function. What are those? The first one is it has been widely used in the empirical studies of manufacturing industries. Its usage is important or has been used in the empirical studies in the manufacturing industries, okay, and in inter-industry comparisons. When two or more than two industries are compared with each other, then also Cobb-Douglas production functions are used. Second one is it is used to determine the relative shares of labor and relative share of capital in the production process. This is an important assumption that we study in the Cobb-Douglas production functions. That is, we can determine how much share of labor and how much share of capital is used in the production process. Okay, it is used to prove Euler's theorem. A very important property again. That is, Euler's theorem is proved through the Cobb-Douglas production function. We have studied Euler's theorem in detail. And now the fourth one is its parameters alpha and beta represent the elasticity coefficients that are used for intersectoral comparisons. Again, what is the role of the alpha and beta? They represent the elasticity coefficients and they are used for the intersectoral comparisons. That is, let's suppose that one is agriculture sector, the other one is manufacturing sector. Now alpha and beta can help us identify which of these sector is using more of labor and which of these sector is using more of capital. Therefore, for intersectoral comparisons also, we can use these elasticity coefficients. Now the production function is linear homogeneous of degree 1. The last property is this production function is homogeneous of degree 1, which shows constant returns to scale. That is alpha plus beta should be equal to 1. Okay, if alpha plus beta is greater than 1, then there are increasing returns to scale, and if it is less than 1, uh, it is then we have diminishing returns to scale. Okay, so therefore what happens is that this Cobb-Douglas production function is homogeneous of degree 1, which shows that constant returns to scale. The last one is that economists have extended this production function to more than two variables. Now economists have incorporated other factors also, such different factors like raw material is used, the factors like human resource is now used in the Cobb-Douglas production function, and several other variables are also incorporated into the Cobb-Douglas production functions. Now this is the concept of Cobb-Douglas production function which we have studied in detail. Now we will move towards the Leontief technology function in our next lecture. Therefore, this lecture is complete over here. If there is any question, you can ask me. Thank you.